Alright, 7.2, Part 2. We're going to be revolving regions that are not laying on the axis that we're revolving around. So our rectangle, this representative rectangle here, will have a space between itself and the axis of revolution. So when you revolve it, it creates a disc, like a washer. Not a disc that we've had before in the previous lesson where it's a complete filled-in cylinder, but it'll be a washer. Or a donut if you want, but it's a really flat donut. Okay, so it's got this hole in the middle. The distance from the axis of revolution to the farthest edge is called capital R, the outer radius. And then the distance from the axis of revolution to the nearest edge is called the inner radius, little r. And if you're trying to find the volume of the solid of the outer radius, you're going to square that outer radius. So it would be pi times the integral of the outer radius squared. But then if you want to subtract that hole, that donut hole in the middle, you're going to subtract the volume of the inner part, that hole, which is going to be pi times the integral of the little radius squared. So notice we square them separately. That's different than something like this where we had yesterday, where we had a function like this. And if you're rotating around this axis, the region that you're rotating is completely laying on the axis of revolution. So when you spin this representative rectangle around, it's not going to have a hole in the middle. So you're going to integrate top function minus bottom function and square that. So see the difference here. This one is just top minus bottom. That whole thing is squared. Here, each individual function is squared. Very different than this. These are very different. So this is washer, where there's a hole in the middle, and this is disk, where there's not a hole in the middle. So for example, if we have this region with a straight line here and a curved line here, this outer radius, we're going to rotate around here. So the farthest distance away from the axis of revolution is that first function, and the closest distance here is the second function that's going to be squared. Notice that that rectangle is always perpendicular to your axis of integration, or the axis of revolution. So you know you have to integrate with respect to x. If we're rotating around an axis this way, if we have some region over here, we're going to rotate with respect to y, and we're going to have our integration with respect to y, all of our equations with respect to y, etc. So let's do this one. Find the volume of the solid formed by revolving y equals the square root of x, which is this function, and y equals x squared, which is this function, about the x-axis. So we're revolving around this x-axis here. Our first step would be to find where these two functions intersect. So I'm going to square both sides after I set them equal to each other, and I'll get x equals x to the fourth. Subtracting x from both sides, I get x to the fourth minus x equals 0. Factor out the greatest common factor. You get x times the quantity x cubed minus 1. Set each factor equal to 0. And solving, you get x equals 1 and x equals 0. So those are those two values. Our rectangle always has to be perpendicular to the axis we're revolving around. So we're going to revolve around the x-axis. So we need x values here. So those are our limits of integration from 0 to 1. And our region is not touching the axis of revolution. So we just don't think about top minus bottom. You think about outer radius, and you square that, and then inner radius, so the closest one, and you square that. Closest to the axis of revolution. And this one's farthest from the axis of revolution. So our integral is going to be pi times the integral from 0 to 1 of x minus x to the fourth with respect to x. So integrating, we get x squared over 2 minus x to the fifth over 5 from 0 to 1. Plug in a 1, you get 1/2 minus 1/5. Plug in the 0, you get 0. Getting a common denominator, we've got a 10 would be good, so 5/10 minus 2/10. 3/10 times pi. Find the volume of the solid formed by revolving the region y equals 2x squared. So it's a steep parabola. Y equals 0, which is this line, and x equals 2, which is this line. So what's my intersection point? I know this one's 0, 0. If you plug a 2 in there, you get 8, so 2, 8. Revolving around the y-axis. So our rectangle is going to be this way. So outer radius is going to be this distance, and inner radius is this distance. So the distance from the axis of revolution to the farthest side is 2 units. That's a straight line here, x equals 2. So our integral is going to go pi times the integral of the outer radius squared minus the inner radius. So I need this distance here. Well, it's represented by this equation, but I need to solve it for x, because everything has to be in terms of x. I mean in terms of y, because I'm integrating with respect to y. So take the square root and you get positive n negative y over 2. But I only want the positive side. I don't care about this stuff over here. So positive y over 2 is the function. That's the distance from here to this curve. So positive square root of y over 2 with respect to y. And my limits of integration have to be y values, so 0 to 8. So pi times the integral of 4 minus, and then that is going to be y over 4 from 0 to 8. So integrating, I get 4y minus, add 1 to the exponent gives you y squared, and divide by the new exponent. I already had a 4 down there, and I'm dividing by 2 also. So 4 times 2 is 8 from 0 to 8. 4 times 8 is 32 minus 8 squared is 64. 64 divided by 8 is 8. And then plug in 0 and you get 0. So 32 minus 8 is 16, and 16 times pi is 16 pi. Okay, find the volume of the solid formed by the same 3 functions, y equals 2x squared, x equals 2, so again we have 2, 8, and y equals 0. So the same region here. This time we're revolving around the x-axis. So notice this is just a disk method because our region is completely laying on the axis of revolution. So top minus bottom, and square that whole thing. So you see how you need to keep things straight in your head? That we're doing a disk method here. We don't have a hole, so we do top minus bottom and square the whole thing. We only square them individually when we have a hole in the center of our region that we're creating. So this is going to be 4x to the 4th, and we're integrating that from 0 to 2. So it's going to be 4x to the 5th over 5 from 0 to 2. So that would be 2 to the 5th is 32. 32 times 4 is 128. So we have 128 pi over 5. Minus 0. Okay. Find the volume of the solid, same region. X equals 2 again, y equals 0, but we're going around the line y equals 8. Remember this point was 2, 8. So now we're going to rotate around the line that goes through there. Around that line. So does this region completely lay on the axis of revolution? No, it's just touching in one point. So our rectangles have to be perpendicular to the axis of revolution, and our outer radius is the distance from the axis of revolution to the farthest side, which is all the way to here. So how far is that? That's 8. So that's the outer radius squared, minus, and then I need this distance here. Well, remember that the distance between the axis and the function is the function. And the distance from the axis up to 8 is 8, and I want the difference between those two. I want this part. So that's going to be 8 minus the function. That's this distance right here. That's the hole. That's the donut hole that I'm cutting out. I need to square that because you square each one individually. Outer radius minus inner radius. Square them individually. Integral from pi times the integral from 0 to 2, because these are x values. So that's going to be 64 minus, and you've got to do FOIL on this, 64 minus 32x squared plus 4x to the 4th with respect to x. So 64 minus 64 is gone, and we'll just have the integral of positive 32x squared, remember to distribute that negative, minus 4x to the 4th So it's 32 x to the third over 3 minus, that looks like part of that, minus 4x to the fifth over 5 times pi from 0 to 2. So you work that out and you're going to get 896 pi all over 15. So let's go over that setup again. Our region, let me make this bigger. Y equals 2, x squared, x equals 2, so this is the point 28, y equals 8, but this is the region that we're revolving, we're just revolving it around this axis. So our representative rectangle is perpendicular to the x-axis, and it's in this region, so the outer radius is the distance from here to here, which is 8. You can think of finding the distance between two lines as top minus bottom, but just remember that when we're doing the washer method, we square them individually. So this part here, this distance here that I need, my inner radius, is considered top minus bottom. You can think of it that way, 8 minus 2x squared to get that distance, but you square it completely because that is the inner radius. So you square the outer radius separate from the inner radius. And that's how that setup goes. Okay, same region, revolving around a different line. Y equals 2x squared, x equals 2, y equals 0, so this region in here again, but this time we're revolving around the line x equals 2. So we're totally laying on the axis that we're revolving around. So is it disk or washer? It's disk. So we need y values, 0 to 8. We're going to solve our equation for x, which we've already done, so I'm not going to go through that again. And now I need the representative rectangle. My rectangle is going to be this distance here. So remember, this distance from here to here is 2, and this distance from here to here is this function, square root of y minus square root of y over 2. I need the difference between those two. So right minus left, that whole thing gets squared because I am doing a disk method. Any questions about that? You'll have to ask me tomorrow because I can't hear you if you're asking. Right minus left gives you the distance from here to here. The right side minus the left side gives you the rectangle that you're revolving, and we square them together because our region is completely laying on the axis that we're revolving around, so we don't want to create a hole. All right, so then when you square that, you'll get 4 minus 4 times the square root of y over 2 plus y over 2 squared, square root of y over 2 squared, which is y over 2. So that's going to be, throw it in the calculator, 16 pi over 3. All right, these notes have gone on long enough. There's your homework.